Hello, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Energy in Motion. This is a student reader in Unit 5. Energy in Wind. Windmills in Holland. The Netherlands is a country. It is located in Northern Europe. It is famous for its many windmills across the country. Windmills have an important job in the Netherlands. They help people remove water from land. This was necessary because its land is not much higher than the sea. The name the Netherlands means lower countries. Much of the land is below sea level. Windmills pumped water out of the lowlands and back into the rivers. This allowed people to farm the land that used to be covered by water. The Netherlands is located in Europe. This is a windmill. Matter and energy interact. Windmills pump water because they capture the energy in wind. Wind has energy because it is moving air molecules. When air gets cooler, it begins to sink downward. When air warms up, it rises. This motion creates wind. Energy is the ability to do work. Work is any change in position, speed, or state of matter due to force. Unlike matter, energy is not made up of atoms. However, matter and energy are always interacting. Matter can only change when enough energy is present. Wind is moving air molecules. Air is a gas. There are different forms of energy. Energy can change from one form to another. Potential energy is energy that is stored. For example, all matter has a form of potential energy called chemical energy. This energy is stored in atoms and molecules. We eat food because food has chemical energy. Our bodies need that chemical energy to survive. Kinetic energy is the energy of motion. The more kinetic energy something has, the more work it can do. When the wind blows, it has kinetic energy. Food has chemical energy. Wind has kinetic energy. Balancing forces. Windmills pump water in the Netherlands because they capture the wind's kinetic energy to do work. This is possible because wind produces a force when it hits the windmill's blades. Remember that a force is a push or pull that acts on an object, changing its speed, direction, or shape. Without force, nothing can move. When all of the forces acting on an object are balanced, the object will not change its position. Balanced means that all of the forces acting on an object are equal. Unbalanced means that the forces acting on an object are not equal. If you want to change an object's movement, there has to be an unbalanced force acting on it. An unbalanced force can change the speed or direction of the object. Wind provides the unbalanced force that moves the windmill's blades. Wind provides an unbalanced force. Doing work. The force of the wind transfers some of the wind's kinetic energy to the blades. When energy is transferred, it moves into or out of an object or system. This transfer of energy causes the blades to turn. The faster the wind blows, the more work a windmill can do. This is because a strong wind has more kinetic energy than a light wind. The more kinetic energy something has, the more force it produces. When a strong wind blows, it pushes against the windmill blades with greater force. This greater force transfers more kinetic energy to the blades. That kinetic energy transfers through the windmill to the machine doing the work. This is why windmills do more work when the wind blows faster. So here's the wind, which is the kinetic energy. And here is the rotating windmill, also kinetic energy. And this is the work. Designing a windmill. People who design windmills want the windmill to do as much work as it can, but people cannot control how strongly the wind blows. Instead, they focus on the design of the windmill. This is because the design of a windmill also affects how much work it can do. To do the most work, the blades of a windmill need to be balanced. They need to be the same shape and the same size. The blades are attached to a rotor hub. The rotor hub rotates or spins. The blades need to be attached to the rotor in equal distances from one another. They also need to be angled so they can catch the wind. The rotor is itself attached to an axle. An axle is a rod that can spin. The axle is attached to another machine that does work. The windmill has different parts that work together. The rotor, which has the rotor hub, the blade, and the axle. And here's the work. Balancing a windmill. The weight of the blades has to be evenly spread out around the rotor. When the windmill blades are positioned at equal points around the rotor, the weight of the rotor is balanced. This causes the rotor to spin smoothly. If the blades are unbalanced, the windmill may wobble as it spins. This will cause it to do less work or not spin at all. Too much friction will also cause the windmill to spin less easily. Friction is a force that slows motion whenever two objects rub against each other. Friction slows motion because it causes some of the energy of the moving object to change into heat. Friction is why your hands feel hot after you rub them together. Friction can cause a windmill to spin less easily because it transfers kinetic energy out of the windmill. Friction can occur anywhere two moving objects rub against each other. For example, it can occur on a windmill between the axle and the parts of the windmill holding the axle in place. Here's an unbalanced blade position, and here's a balanced blade position. Patterns in motion. Patterns in wind. The state of California is home to the largest wind farm in the United States. A wind farm is made up of a kind of windmill called a turbine. Wind turbines capture the wind's energy to produce electricity. The California wind farm is located in the mountains. Mountains are very windy. Coastlines along the ocean are also very windy. Remember that the stronger the wind is, the more kinetic energy it has. People build windmills in places that they know are windy. This is because windmills in windy places are able to do more work. This is a picture of a wind farm in California. Predicting motion. There are patterns in how a windmill moves. There are patterns in motion all around us. These patterns can be used to make predictions about future movement. For example, when you move back and forth on a swing, your motion follows a predictable pattern. First, you cannot move on the swing unless an unbalanced force causes you to move. This can come from someone else pushing you or pushing off the ground with your feet. Once you are in motion, the swing moves back and forth in a predictable way. It will take the swing the same amount of time to complete each swing. You will keep moving like this until another force slows you down. For example, air resistance will slow you down. Air resistance is similar to friction. It turns motion energy into heat. This movement of this swing follows a predictable pattern. However, the motion of a swing depends on several variables. For example, a swing with a longer chain will take longer to complete one swing than a swing with a shorter chain. The motion of a swing also depends on who is swinging. For example, an adult needs more force to move than a child needs. This is because more massive objects need greater force to make them move. Remember that mass is a measure of the amount of matter that makes up an object. The more force you push off the ground with, the higher and faster you will swing. If you push off the ground with a little force, you won't swing very high or very fast. More force will cause you to swing higher and faster. I learned a lot reading Energy in Motion, and I had fun too. I hope that you learned a lot and that you had fun also. I'll see you tomorrow with another one. Bye.